The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees.
I just noticed that I put April 18th, 2016A. I don't know if there's a 2016B somewhere around, but apparently, yeah.
There's an infinite number of options.
Yeah. So anyway, I'm going to give you kind of a timeline story of roller compacted concrete in Texas, and we're not going to get into a lot of the technical design details, and I'm going to talk about this evolution in terms of the many projects that have occurred in Texas over the years, and try to bring in how some things have changed and some things have stayed the same. I'm going to give you just a real brief introduction. Most of you, I'm kind of preaching to the choir here, so this is old stuff, but in case there's a few of you not in here, one of the things, especially when I'm talking to people who are not immersed in concrete and especially not in concrete pavement, they really get really confused about the different kinds of concrete pavements there are. In Texas, I would say, unfortunately, we have still, and they're still being built, a lot of jointed reinforced concrete pavements. So you have these like 80-foot panels with light reinforcing, and then these redwood expansion joints, and then dowels, and there's a lot of that in Texas. Not DOT stuff. This is local pavements. The DOT, TxDOT, opts for continuously reinforced, and driving up here on the tollway, I had to drive from Chicago because of weather back at home and connections, but there's some really nice Illinois toll road that's continuously reinforced, I noticed, but virtually all the TxDOT roads, highways that are concrete are continuously reinforced. And of course, that's heavy reinforcing that forces about 3 to 8 foot cracks in the concrete. There are no saw cuts in continuously reinforced transversely. Then you have your jointed plane, which we're trying to graduate these people from jointed reinforced to jointed plane concrete at the local level. And of course, you can, depending on the pavement type and thickness and things, you can either dowel it or depend on your aggregate interlock. And of course, there you're dealing with much shorter joint spacing than the jointed reinforced type pavements. And then you have roller compacted concrete, which really is a type of jointed plane concrete pavement. You can't put dowels in it, so if you do have heavier truckloads, you have to take that into account with your base design and your thickness design. But roller compacted concrete is nothing more than really a subset of jointed plane concrete pavement. Now, very quickly, I'm not going to dwell on this stuff, but RCC is just a concrete pavement that's placed in a different way. It's very stiff, no slump concrete. You see a sample in a guy's hand there. There are no forms, no reinforcing steel, and it's generally placed with asphalt-style pavers, usually these heavy-duty type pavers that have dual tamping bars and vibrating screeds that you get a lot of compaction right out of the paver. And then it's consolidated with the vibratory roller, and there's no finishing generally. That's changing a little bit too, but there's no finishing, and your water cement ratio tends to be very low on these things, relatively low. Your water content is low. You usually have a pretty well optimized aggregate in these things, and so there tends to be less shrinkage in this type of concrete than conventional concrete. So just taking a look at RCC versus conventional paving, if you look at RCC versus asphalt, and that's a picture of RCC and asphalt right next to each other, it can be less expensive. Not all the time. It's rigid, so because of its rigidity, you get away from some of the subgrade stress issues that may crop up with an asphalt pavement, and you certainly are going to have less thickness of the pavement because of the rigidity. Ultimately, if you do it right, you're going to have less maintenance, and your placement time is going to be usually the same or less than an asphalt pavement. If you think about an asphalt pavement, if you have several inches of asphalt, you're going to be putting it in thin lifts. RCC, you can go up to 10 inches in a single lift. So even though it's out of an asphalt-style paver, you can get that whole lift in one fell swoop. If you have a 6-inch, 8-inch, 10-inch lift, you get that all in one pass. The downside is asphalt can be smoother than freshly placed roller compacted concrete, so you need to take that into account. If you have higher traffic, you may need to do other things with your RCC, like maybe grinding it, looking at a diamond grind, or maybe even putting a thin asphalt overlay on top to round out that surface. Now, if you look at it versus conventional concrete, it's always less expensive if you have the right size and scale of project. You don't have reinforcing or dowels in this at all, so you get rid of that expense, but there's also faster and higher production that generally you can take advantage of with RCC. Additionally, because of the stability of the mix without even any hydration taking place, if you absolutely have to, you can get some light traffic on that, hopefully not heavy trucks, but light traffic on it even before 24 hours. If someone has to pull into their driveway, it's usually okay. And then after a day or two, usually you have enough strength to allow heavier traffic on the RCC. It gains strength pretty quickly. And at higher speeds, you can grind the roller compacted concrete, as I mentioned before. The disadvantage is you can get conventional concrete paving to be much smoother than RCC, but you can do things to the RCC to make it just as smooth ultimately, but it may take that additional step of either grinding or, again, putting a thin asphalt overlay on top. One thing that's important in any RCC is that the project size and the project complexity can really dictate the economic benefits. So there are some projects that are going to be very conducive to RCC, and that's why you've seen it in large industrial applications where you just have acres and acres of blow-and-go concrete paving. Well, you can just flat out put out this RCC, not a lot of complications, and you really get this high economy of scale. The more complex, the more manholes and curbs and intersections and all kinds of things like that tend to reduce your economic benefits. And then if you have small projects, it's usually harder because a lot of the RCC is done with scale in mind. So you're producing roller compacted concrete out of a pug mill a lot of the time and using these ABG or high density pavers. And you have to have a project of a certain size to justify the mobilization costs. Now, there are a lot of areas in the country that have gotten into ready-mix producers making RCC at a fixed plant and using conventional asphalt pavers. What I will tell you, since we're talking about Texas, is this has not caught fire at all in Texas. There have not been any of those types of projects to speak of in Texas. Generally, it's done with the traditional heavy-duty paver and pug mills or central mix plant or something else. Now, with RCC, there's been some growing pains. Between the 1980s, mid-80s, and the 2000s, what we were dealing with mainly was just a lack of experienced contractors nationally. There were 2, 3, 4 guys around the country that actually knew what they were doing with RCC, and you had to have a project big enough to attract them, so it was kind of slow going. And I know this intimately because at that time period, since the 1990s and into early 2000s, I was PCA's national program manager for roller compacted concrete. I was promoting this, and really the best success I was having were things like really large distribution or intermodal type facilities, things like that. You also have the problem with one bad project can hamper a market or owner in a region. So if someone is unfamiliar with RCC, they place it and they really screw it up, well, that RCC is no good. People can tell you horror stories about this happening. We've had it happen occasionally too. I've already mentioned project size, especially when you're getting into these pug mill and high-density paver situations. The large projects are the ones that are more conducive to an economic advantage with RCC. And then the equipment requirements tend to be very specialized. Your typical highway contractor or local concrete contractor doesn't have the right equipment to produce it or place it if they're going to use the pug mill and the high-density asphalt paver. You can, again, use a ready-mix plant in a conventional asphalt paver, but again, in Texas, that hasn't occurred. The types of projects that have RCC started off for the first at least couple of decades, mainly just these large industrial ones, but now, as you'll see in my project timeline that I'll show you, we're getting much more into public roads and smaller projects or projects of lesser scale, which I think is a good thing. Some other problems, growing pains, is over and under specifying the RCC. You don't want to over specify it so much that you're going to scare contractors away. You got to watch the spec and not make it too difficult. And then, of course, underspecifying is another problem. If you don't have enough controls in there, the contractor is going to be able to get away with lots of things. The other problem that we've run into sometimes, and we've run into this, I'll mention TxDOT in a little bit. They're just starting to get experience with RCC, but we kept telling TxDOT, hold the contractor to the specification. Hold them to the specification. They weren't over-specified, but the contractor, who was a relative neophyte, was doing things that were outside of spec, and TxDOT did not insist that he do that, and it's difficult to come back. You can't make the contractor rip up everything when you didn't stop them and say, you need to change the way you're doing things. So you got to have the proper quality control and inspection and things like that on the job. And you also have to manage expectations. RCC is not going to look like conventional concrete. You know, we've showed you here what the surface looks like. It's not going to be as uniform as conventional concrete. You have to inform the owners and the inspectors and the engineers about this. So let's talk about RCC again. And I'm going to throw this out that Texas really was sort of the birthplace of RCC pavement in the U.S. Now, some people may take exception. There may have been in the Pacific Northwest maybe a little bit of RCC placed up there because really it got its start in the log yards in Canada back in the late 70s. But really in the U.S., that same guy that I mentioned before that's sitting here was a young, good-looking graduate student, PhD, at University of Texas, and he decided to do, I guess, your dissertation on it. I don't even know how you decided on this crazy thing called roller compacted concrete. And I think by his interest, he got it incorporated into some projects in Texas, the first one being Fort Hood back in 1984. That was about 18,000 square yards, 10 inches thick. At the time, which is a long time ago, cost $58 per square yard, but that pavement still exists at Fort Hood today, and it's used for all kinds of maintenance and tank trails and that kind of thing. And it's interesting, one of my colleagues, Matt Single, went very recently to Fort Hood to look at this, and the engineer who's in charge of this now really didn't even know what he had there, you know. And Matt actually told him, well, this is RCC, it's been sitting here for, last 30 years, and he said, wow, we should do more of this, what the heck. So anyway, they did another project out at Fort Hood. They started with fairly large aggregate, and we found, this is where you get into some of the learn by doing things very quickly, that you couldn't use 1.5 inch aggregate. You're going to get something that doesn't look so good. They quickly went to 3/8 of an inch aggregate, and the surface essentially was much better. And now 1/2 inch or 5/8 aggregate tends to be the norm. 3/4 of an inch, most contractors will tell you, is going to be a pretty rocky mix right there, and your surface isn't going to be looking that great. It was placed in very hot and windy weather, and this is another thing that kind of went through an evolution. There were no saw cuts. We talked a lot about saw cuts today. No saw cuts here. It was allowed to crack naturally, and for the first 25 years that we were placing RCC, this is kind of what we preached. You're putting down a really economical pavement, usually for heavy-duty purposes. You don't really care that much what it looks like. You want it to be serviceable, so let it crack naturally. Let it do what it wants. And that's what a lot of projects, the core projects, and a lot of intermodal yards did. And some are still doing. That has changed very much because most RCC projects now are saw cut. And we'll talk a little bit about that as we go on. So anyway, this is the Fort Hood project. So thank you, David, for starting us off with RCC. Because that Fort Hood is relatively near Austin, there are some projects that kind of piggybacked off of the contractors being out there and people being aware of this. Central Freight built a truck terminal in Austin in 1987, and they used 7 and 8 inch pavements, about 90,000 cubic yards, and the RCC was actually bid at 25% less than asphalt. So this is a case of RCC was definitely less expensive. Again, it was let to crack naturally, and the natural cracks were up to 50 feet apart. So this kind of attests to some of the lower shrinkage of the RCC. This was in continuous use, and what you see in that picture was taken probably less than a year ago. It is no longer a Central Freight terminal. They sold it to a contractor who does long hauls for the post office. They use part of it for a maintenance yard for their trucks. The other part they're leasing to UPS, so the warehouse part, the part that gets most of the trucks, is getting new use. They did have to replace about 10% of it. after almost 30 years of constant use, and most of that was due to really poor subgrade conditions. So a lot of it just was subgrade failure, not necessarily bad RCC or anything like that. It's still used presently for UPS and for a long-haul postal contractor. I try to mention the contractors in most of these. Pelts. There's also another early project in the Austin area called Hornsby Bend. This was a compost facility there built in two iterations, one in 1987 and one in 1990. Now, this compost facility takes all of the wastewater sludge and converts it into something called dillo dirt. That is actually a commercially viable product, and they sell it to commercial landscapers as dirt. So essentially, they take all of Austin's sludge and recycle it into compost, and they've been doing that for 30 years. Well, when they placed the RCC down here, they actually made it 2 to 3 inches thicker than the actual design required, because they figured with all this scraping, because this stuff gets scraped daily, that they had a sacrificial surface on it that would wear off eventually. After a couple years, the RCC did not change at all. So the second section that they put in, they were able to reduce the thickness by 3 inches on this. Again, that was placed by Peltz. And then in 1999, a border station was placed. It was under-designed based on the traffic that they actually had, and it had to be replaced in about 2011. But for those years, it gave pretty good service. But really, the problem was they had more traffic and heavier trucks than they originally projected. This is down near Brownsville, which is the southern tip of Texas. This is the project that really brought the renaissance, because for a while, RCC was not built very much in Texas. Port of Houston, between 2007 and literally right now, 2016, really surged a renaissance of RCC in Texas. And here they built, between 2007 and now, there are 4 projects. You can see 45, 48, 35, and 30 acres of 14 and 18-inch thick RCC. This is a lot of RCC. Right now, this is the largest by cubic yard RCC installation in the United States. What they did was originally they bid it with conventional concrete. You can see that at the very bottom where I say costs. And it was generally about 10 to 20% less than conventional concrete, so that now they just bid it RCC. Now, these are projects that are right on our heels with the Port of Houston. A lot of this has to do with the Panama widening and deepening, and you can see that between right now, and they're just finishing up another project that's on this page, but between now and 2019, that all the additional acreage that's going to be placed there, by 2020, essentially, the Port of Houston will have at least 380 acres of mostly 18-inch roller compacted concrete. That's about 1 million yards of RCC at the Port of Houston. And if you made that into a 6-inch thick, 12-foot wide lane, that would go almost across the whole state of Texas, almost 800 miles. Not that you necessarily want that to happen, but that's a lot of RCC. I'll just mention a few other things. This is now where we're going with RCC. A lot of the cities that are traditionally asphalt cities, like West Texas city of San Angelo, they're building arterials out of RCC. They built 2 arterials. These are several years old now, and they're performing beautifully with RCC. Additionally, a lot of industrial sites, you can imagine with the oil work and petrochem work, there's a lot of industrial sites in Texas. This is just an example of one of them, a 60-acre site where they placed RCC, and this was actually cheaper than graded aggregate with no surface on it. This was actually 20% cheaper because they could go so much thinner on this and have essentially zero maintenance. In Midland, Texas, another arterial. This is a true inlay where they actually milled out the asphalt, and for a 4-lane road, 2 of the lanes, the first 2 lanes took 4 days to construct, and the last 2 lanes took 3 days to construct with the roller compacted concrete. So this is very quick, and they actually bid this against asphalt. So it was 3.5-inch asphalt on 12-inch base or 7 inches of RCC using the recompacted existing base. RCC was a little more expensive, but they justified it on life cycle cost. And Reese Albert was actually, they're an asphalt contractor. They bid RCC, and they were experienced at RCC, but they also were the low bidder on both projects. One of the last things I wanted to mention to you is this right here. This is in Liberty County. In this particular development, the developer found that he was having a lot of problems with the traditional 2 inches on 6 inches of base street standard, having to go back and do a lot of repairs over the warranty period. He could get 5 inches of RCC on a stabilized base for about the same cost. And since that point in time, and Liberty County is essentially a far suburb of Houston, he has placed over 60 miles of streets, nearly 1 million square yards of RCC. And this is just in the last 2 to 3 years. And finally, I'll mention that TxDOT is beginning to use RCC, and unfortunately on the first TxDOT project, that's where they got into not holding the contractors' feet to the fire. They know better now, but that did not spoil them. Thankfully, they have some good forward-thinking people there, and they're trying it on a number of other projects at TxDOT. And with that, I hopefully took you for a little tour and a timeline of Texas projects.